Very good morning, friends. Myself, Professor Chirag Shah, lecturer in Mechanical Engineering, Government Polytechnic, Ahmedabad, welcomes again in this video series lecture on Basic Engineering Drawing. Our topic of discussion is on engineering curves. In the previous lecture series, we have already learned what is the importance of engineering curves. I hope you all are aware with the various engineering curves which you are seeing in your daily life. I hope you also see the various engineering curves in bridges or arches and also in your household, your shape of tray. So all engineering curves you aware. We have also discussed in the previous lecture that what is conic sections. How can you get the various shapes like circle or triangle by cutting the cone at various angle. You also experience that in your house also by cutting carrot. You can also see the view by cutting the carrot in a various position. So you can get the different curves like circle or parabola or ellipse. We have also learned the various method of construction for ellipse like concentric circle method, rectangle method, oblong method, then arc of circle method, and also rhombus method. We have also learned Directrix-FOCUS method, which is based on the definition of ellipse. You also know the definition of ellipse, that it is the locus of a point moving on a plane such that its distance from the fixed point called locus and to the fixed line called directrix is constant and it is less than 1. So you understand what is ellipse and how the method of construction, how you can draw an ellipse by various methods. I hope you also practice at your home various method of construction, whatever you learn in the previous lecture series. In this session, I am going to deliver one more method of Directrix-FOCUS method for ellipse. Also how to draw tangent and normal to this curve ellipse. Then what is parabola, what is hyperbola, and how these curves are drawn by various methods. So first of all, I am going to deliver how to draw an ellipse by Directrix-FOCUS method. In previous lecture series we have also learned this method, but this method is different. So first see how you can draw an ellipse by Directrix-FOCUS method. The problem is same. The distance is given from directrix to focus, it is equal to 50 mm, and eccentricity, as you also know what is eccentricity, it is the distance from the focus and distance to the directrix. It is a ratio of both. So here eccentricity is given. Let's see how we can draw an ellipse by this method. So first of all, draw a directrix which is given the name AB. Now at 50 distance perpendicular to this directrix, draw an axis, and at 50 distance, locate focus which is at a distance of 50 mm. Now divide this distance of 50 mm into 5 equal parts and locate point V such that its ratio from focus to the directrix is 2/3, means from point F locate point V such that its distance from the focus to the directrix is 2/3. So from F, 2 parts, locate point V which is at a distance of 3 parts from the directrix. So eccentricity is 2/3. So this is the point, first point you can say, from which the ratio of its focus and directrix is 2/3. Now locate similar points having the same ratio of 2/3 such that you can draw a ellipse. So draw a vertical line which is equal to 45 mm distance, and from focus F take an arc of 30 mm such that these arc intersect the vertical line which is drawn at a 45 mm distance from the directrix. So you can get one point which having the ratio of 30 by 45 is equal to 2/3 ratio. Now forming similar points on bottom of the axis and also draw similar vertical line having a distance of 60 mm from the directrix and 40 mm from the focus, and cut this arc at this vertical line, we can get another point. Similarly at bottom side locate that point. Likewise draw third vertical line which is at a distance of 75 mm and from focus F take a distance of 50 mm. So 50 divided by 75 is equal to 2/3 eccentricity. Likewise in bottom of the axis locate all these points which are at a distance of having eccentricity of 2/3, and by joining this point we can get a ellipse. So here by drawing a vertical line which is at a distance of 45 mm, 60 mm and 75 mm, draw 3 vertical line to the right side of the vertex line, and from focus and having a radius of 30, 40 and 50 mm which intersect with this line so that the eccentricity value is 2/3. So this is another method of drawing ellipse by directrix focus method. This is a step-by-step procedure how to draw a directrix focus method, what we have drawn. So from this step-by-step procedure you can also draw another problem by this method by taking different data. Now let us understand how you can draw a tangent and normal to this curve which is known as ellipse. So how you can draw tangent and normal to the curve? Let us understand. The data is given. You have already drawn an ellipse. Now from point Q on the curve, let us locate point Q on the curve ellipse, given the name Q. Now join Q with the focus F. Now draw a 90-degree angle QFT. The T is at a directrix line AB. So you can get point T. Now draw TQ, which is a tangent to this curve, and this is a normal which is perpendicular to this tangent. So here TQ is a tangent and NN is a normal to this curve. So I hope you can understand how you can draw a tangent and normal to this curve ellipse. Now let us see how we can draw tangent and normal to the ellipse by arc of circle method. You have already know the arc of circle method, which is based on the second definition of the ellipse. So first you have already drawn ellipse by arc of circle method. Now to draw tangent, first select point Q from which you have to draw tangent to this curve. So join point Q to the F1 and also F2. Now bisect angle F1Q F2. This is a normal to this curve. The angle bisector is normal. Now draw a perpendicular line drawn to this normal line, so we can get tangent to the curve. So here TT is tangent and NN is normal. Now what is parabola? As we have seen that the definition of parabola is, it is a locus of a point which moves in a plane so that its distance from a fixed point and a fixed straight line is constant and which is equal to 1. So it is a equidistance from focus and directrix. Here eccentricity value is 1. In ellipse the eccentricity value is less than 1, and for hyperbola eccentricity value is greater than 1. So in case of parabola, the ratio of eccentricity means the ratio of distance from the focus to the directrix is equal to 1, which is at equidistance from focus and directrix. So here you can see the VF upon VC is equal to 1, or you can say PF upon PM is equal to 1, or you can say QF upon QN is equal to 1. So here the position of vertex is at a equidistance from focus and directrix line. What are the application of parabola? You have seen the motor car light reflector. The shape of is like a parabola. So high beam you can reflect at a long distance. Also shape of sound reflector and detector is also like a parabola. Shape used in bridges and arches, you have already seen the shape of the bridges and arches. It is just like a parabola. Also shape of cooling tower and trajectory of a projectile. So you have see the projected missile follow the parabolic curve. Also water jet coming out from the water tank follow the parabolic curve, and you also play the game of badminton in which shuttlecock moves in a parabolic path. So any body moves in a space, if thrown, it follow the parabolic path. There are various methods of constructing for parabola. First method is rectangle method. Second one is method of tangent method, and third one is directrix-focus method that you have already learned in ellipse. So first see the rectangle method, how to draw a parabola by using rectangle method. So the given data is a ball thrown in air attains a 100 mm height and covers horizontal distance of 150 mm on ground. Draw the path of the ball. So here from the given data, draw a rectangle having one side equal to 100 mm with a height of 150 mm. Divide this rectangle in two parts. For construction, select left side of the rectangle. Divide the height and side into equal number of parts. So here you divide the vertical line into equal number of parts. Similarly, the left side into the 6 equal number of parts. Name all those points 1, 2, 3, 4, 5 on vertical side, and similarly 1, 2, 3, 4, 5, 6 on a horizontal rectangle line of left side. Now join vertical points 1, 2, 3, 4, 5 and 6 to the top of the rectangle, just like this. So draw and join this line to the top of the rectangle. Now from horizontal points 1, 2, 3, 5 and 6, draw a vertical line parallel to height, which similarly you can draw on right hand side of the rectangle. Now draw vertical line from 1, 2, 3, 4, 5 and 6 which intersect the line drawn from the vertical side of the 1, 2, 3, 4, 5, 6 line. Similarly, similar construction you can draw on right side. Locate all these intersecting points. Given the name of P1, P2, P3, P4, P6, similarly P1 dash, P2 dash, P3 dash, P4 dash, P5 dash and P6 dash. And by smooth curve you can join all these locating points, you can obtain the parabola. So I hope you understand how to draw a parabola by rectangle method. It is a very easy method to understand. These are the steps. You can take reference these steps to draw another problem of drawing parabola by rectangle method. Here you have to draw rectangle and divide into equal parts. Then considering left part of our construction, divide height and length in equal number of parts and name those points 1 to 6. Now join vertical 1, 2, 3, 5, 6 points to the top center of the rectangle. Similarly draw upward vertical lines from horizontal 1, 2, 3, 4, 5, 6 points, and wherever these lines intersect previously drawn inclined lines in sequence, mark those points and further join in smooth possible curve. Repeat the construction on right side of the rectangle and join all these points in sequence. So this is known as a parabola. Now let us understand how to draw parabola by method of tangent. So here data given is here the problem is draw an isoscale triangle of 100 mm long base and 110 mm long altitude. Inscribe a parabola in it by method of tangent. So from a given data, draw a triangle having 100 mm side and 110 mm of height. Now divide both sides into equal number of parts of the triangle. Name all these points from 1 to 14 on left side and in the ascending order from C to B 1 to 14. So both the name given is in ascending and descending order. Now join point 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, likewise up to 14, 14, 14. Now from all these points, draw a tangent line so that you can get the curve which we can say it is a parabola. So here you have to draw tangent from all these lines, like from line 1, 1, 2, 2 up to 14, 14. You have to draw tangent from each line so that we can get a curve like parabola. So it is a very easy to understand method. Here the main thing you have to keep in your mind that how you can divide this side of triangle into equal number of parts, that you have already learned in geometrical construction method, how you can divide a line. So let us understand another. So this is a step by step procedure of method of tangent to draw a parabola. Take these steps as a reference and draw another problem with the different data. So it is another problem on tangent method to draw parabola. The line AB is given is equal to 7.5 meter. Then height is given. From this data, create a triangle. Take 4.5 mm above point F, so that you can get a apex and draw a triangle. So how you can divide this line of triangle into equal number of parts? Let us understand. First, draw a line at any angle and divide this line into equal number of parts. Here we can divide it in 6 parts. So from this last point, join this line to the point O, and from each point draw a parallel line like this line. Draw a parallel line. So you can divide this side into equal number of parts. This method you already learn in geometric construction method. So similar division you can do in right side of the generator. Name all these divided points in ascending and descending order, or in different manner like 1 dash, 2 dash. Join 1 1 dash, 2 2 dash, 3 3 dash, 4 4 dash, 5 5 dash, and by drawing a tangent from this curve you can get a curve which we known as parabola. Now another method of parabola which you already learn in ellipse, the method is Directrix-FOCUS method. Here the eccentricity value is given. As we know that in case of parabola the eccentricity value is 1, because here point on the path of the curve is at an equidistance from the focus and directrix. So let us take a quick review how to draw a directrix focus, which you already learn in ellipse. The same method you have to apply to draw a parabola. Here the data is given is point F is at a 50 mm from directrix line, and the eccentricity value is 1. So draw a directrix line AB. Draw a axis and locate point F, which is at a distance of 50 mm. Now locate point V such that it is at the same distance from focus and to the directrix. So at 25 mm from directrix or from focus, locate point V. Which we known as vertex. Now draw vertical lines from right side of the vertex at equidistance and given the name 1, 2, 3, 4. So draw vertical line parallel to directrix at equidistance to the right side of the vertex. Similarly, draw on left side of the vertex and given the name 1, 2, 3, 4, 5. Now take F as center and having a radius of F1, F to the 1 on left side of the vertex line. Draw an arc which intersect the line drawn from the 1. So here you have to take a arc of F to 1, this one, and draw a arc which intersect the line drawn from the right side of the vertical line 1. Similarly, take a distance, or you can say radius of F2, F2, and from F as center draw an arc which intersect the vertical line drawn from the line 2. Locate all these points above and below the axis. You can get the various locating points by taking radius F3, F4 likewise, and join these points through a smooth curve. We can get a directric focus method. So it is a different method than previous one. I hope you can understand this method. You can also take a radius of here, if this point is R, so you can take R1 and take F as a center. The point is the same, intersecting point is the same. So here vertex point is at a equidistance, so you can take from here or you can take from here. Take R1 as radius or take F1 as radius. So we can draw a parabola by directric focus method. This is a step-by-step procedure how to draw a directric focus method, how to draw a parabola with directric focus method. Read this procedure and act accordingly to draw another point. Now, how to draw tangent and normal to the parabolic curve? Let us understand how to draw tangent and normal. Here you have already drawn parabola by different method. So parabola is here. Now to draw any point on parabolic curve, like the name is point Q. If you have to draw a tangent from this point Q First of all, join this Q with F. And draw a 90-degree angle FQFT. The point T is at on directrix line. If you extend this line, it intersects at directrix. You name this as a T. Now join TQ so that it is a tangent to this curve. And at 90 degree from this tangent you can get normal. Given the name TT and NN. TT is tangent to the curve and NN is normal. So this is a procedure to draw a tangent to the parabola. Now let us understand what is parabola, what is hyperbola. It is the locus of a point which moves in a plane so that the ratio of its distance from a fixed point and a fixed straight line is constant and greater than 1. As I have already explained the definition of ellipse and parabola, so in case of hyperbola, the eccentricity value is greater than 1. It means the ratio of PF and PM is greater than 1, or you can say ratio of FQ to the QN is greater than 1. Eccentricity value is greater than 1. The various application of hyperbola, as you seen, the shape of Boyle's law graph. You can very well know what is Boyle's law for gas. PV is equal to C. The curve of this graph is just like a hyperbola. Similarly, shape of overhead water tank is like a hyperbola, and shape of cooling tower is also like a hyperbola. The various method of construction for hyperbola are rectangle method. Here coordinates are given from which you can draw a hyperbola. Then PV diagram, so it is also a rectangle hyperbola method, and Directrix-FOCUS method. So first let us understand rectangular hyperbola. How to draw a hyperbola if you are giving a point of known coordinates. The coordinate value is given here, like the point P is at a distance of 30 mm from horizontal and 40 mm from a vertical axis. So here coordinates are given, and from which we can draw a hyperbola. So first of all, draw perpendicular axis OB and OA and locate point P such that its value from point O is at a distance of 30 mm and from vertical at a 40 mm. So locate point P from a given coordinate value. Name the point P. Now draw a vertical line from point P to on the axis, and given the name, divide this vertical line into equal number of parts and name the 1, 2, 3. Similar, draw horizontal line from point P and divide this line into 2 equal number of parts and given the name 1 and 2. Now draw horizontal line which is parallel to the line OA, and from P draw a vertical line which is parallel to OB. Now draw inclined line which is passing through point O1 and which intersect the horizontal line drawn from the point P, given the name. Similarly, draw O2 which intersect the horizontal line drawn from point P. Similarly, on left side, join O1 which intersect the vertical line drawn from the P, and similarly draw a O2 line and extend that line up to the vertical line drawn from the point P. Name all these intersect points in a similar way. On the right side 1, 2, 3, on a vertical side 1 and 2. Now from horizontal point 1 draw a vertical line. Similarly, from point 2 draw a vertical line parallel to OB. Similarly, from point 3 vertical line parallel to OB. And from this point 1 draw a horizontal line. Similarly, this vertical point 2 draw a horizontal line. Likewise, from 3 horizontal line. Locate these intersecting points. Similarly, from here draw a vertical line, and from here at point 2 draw a vertical line. Similarly, from point 1 draw a horizontal line, and from point 2 draw a horizontal line. Locate these intersecting points. Now join all these points, intersecting points, we can get a hyperbola. So I hope you can understand how to draw a hyperbola by this rectangular method. In this session we have learned the remaining method of ellipse, directrix focus method, how to draw tangent and normal to the curve ellipse, and what is parabola and hyperbola, what are their applications, and how to draw parabola and hyperbola with different methods. On this stage, once again remind you and advise all of you that you have to practice more and more to get the perfect, consistent and accurate drawing, so that you can easily understand the concept and you have a very good command on your topic or your drawing. So once again I advise you to practice more and more. Thank you very much.